Hi and welcome back. So in the past video we had been talking about, we had been using this example of a helium atom which has two protons, two neutrons, and two electrons. And pretty much what I was showing you was that most of the mass, and we figured out that it's 99.97% of the mass of this atom is contained within the nucleus, and that there really isn't, there's really a negligible amount of mass that's contained in these electrons. And what I'm going to hopefully show you in this video, didn't mean to go down that far. There we go. What I'm hopefully going to show you in this video is that when we consider the mass of pretty much any atom, we're really only going to consider the mass of the protons and the neutrons. And we're pretty much not going to consider the mass of the electrons, because even, and here I'll do this again, if we were to figure out how many times larger a proton, or how many times more mass a proton has than an electron, and I'm going to get out Google again and pull up the Google calculator, and so I'll plug into it, we'll say 1.672 times 10 raised to the minus 24th. So this is our, move this up, this is our mass of a proton, right? And so we're going to divide that by the mass of an electron to figure out how many times larger an electron is. So we have 9.109 times 10 raised to the minus 28th. And so we get 1,800 times larger, or 1,800 times more mass is contained in a proton than in an electron. And so anyway, really what we're going to see, hopefully in this video, is that the way the mass of atoms is determined is the way the masses of atoms are I guess thought about and kept track of, really only considers the mass of the protons and the neutrons. And we're really not going to worry about the mass of the electrons, just because the protons and neutrons are so much more massive. And another point, in addition to that, to I guess realize, is that the protons and neutrons have got a very similar mass. We've got 1.672 versus 1.675. And so even when we keep track of the mass of an atom, we're going to consider these, the mass of the proton and the mass of the neutron, essentially equal. And in order to, and I guess going along with that, we are going to we're defining a new unit, maybe you've heard of it, but the unit that we're going to define is the atomic mass unit. So atomic mass unit. And essentially what an atomic mass unit is if we say, so we said that in this past example, we had our helium atom, and if you remember, our helium atom had two, well, I'll write it over here. So our helium atom, so helium, and this example of our helium atom, this isotope, if you don't know what isotopes are, don't worry, because we haven't talked about them yet, but this isotope of a helium atom has got two protons and two neutrons. So we have I'll just say two protons, two neutrons. It also has two electrons, but when we're talking about the atomic mass of this entire atom, the mass of the electron is so tiny compared to the mass of the protons and the mass of the neutrons that we're really not going to consider it. So pretty much what we are going to say is that helium has an atomic mass of 4. Or of 4 AMU, for atomic mass unit. So this isotope, because again, we haven't talked too much about isotopes, but this isotope of helium has got two protons and two neutrons. So the way we get our atomic mass, so we could say our atomic mass is going to equal 4 AMU. And essentially, I can write down what the units are for for atomic mass unit, but all you necessarily need to know about the atomic mass unit is it's essentially the mass of either a proton or a neutron. Officially, what the mass of one atomic mass unit, and I'll write this down. If you want to keep track of this, maybe it might show up on a test or something, but the conversion factor for one atomic mass unit is 1.66 times 10 to the minus 24 grams. So it's right about, it's actually not in between, and maybe I'll try to figure out why exactly it's not directly in between the mass of a proton and the mass of a neutron. But it's almost the same. It's almost the same as, it's right around in the ballpark of the mass of a proton or the mass of a neutron. And essentially, all you even have to remember about the atomic mass unit is if we had another atom, and we'll definitely talk more about this, but say we had another isotope of helium. And an isotope is just essentially, and I'll definitely talk more about this in a future video, but an isotope is essentially an atom. An isotope is essentially an atom that has the same number of protons. So if we say helium, and I'll definitely talk more about this in the future, but helium, what defines the helium atom as a helium atom is the number of protons. So if we have an atom that has 2 protons, that is always going to be a helium atom. And definitely more on that later, but if we have 2 protons, that's always going to be a helium atom. And the most common isotope of helium has 2 neutrons. But we could have another isotope of helium. So we could have an isotope of helium which has 2 protons. Again, this is what is going to define it as helium, is the fact that it has 2 protons. But then we could have an isotope which had 3 neutrons. So if we said for this isotope our atomic mass was 4 AMU, what would the atomic mass of this isotope be? So we've got 2 protons, 3 neutrons, and remember, it doesn't matter how many electrons we have. This is, it's a neutral atom, so we're going to have 2 electrons to balance out the positive charge from these 2 protons. But in determining our atomic mass, it really doesn't matter because the mass of the electron is so much smaller compared to the mass of the proton and the neutron. So this would be 5 atomic mass units, right? Because we would just add the mass of the proton to the mass of the neutron. So essentially, this is, I guess, officially, and maybe I should have written out all the different digits of what this is. Actually, let me write down at least a few more digits. We could say that this is that an atomic mass unit, so write this down, 1 AMU, 1 atomic mass unit is equal to 1.66053, what else did I write down? 886 times 10 to the minus 24 grams. So if you want to write this down, it definitely can't hurt. Probably you're not going to need. We'll do one example, and it's even just an example to prove a different concept we're going to talk about later on in the playlist, where we are going to use this number, but probably in the course of your chemistry class, you're not going to be needing this conversion factor to know that 1 AMU is exactly this many grams. But it might be useful to just write down, so if you ever do need it, you can just refer to it in your notes. But the important thing that I wanted you to get out of this video is that essentially, when we talk about atomic mass, we're only considering the protons and the neutrons. We're not considering the electrons at all. And also the other thing I wanted you to get is that the atomic mass unit is essentially it's essentially the mass of either 1 proton or 1 neutron. And again, the neutron has got a slightly larger mass, but when we're talking about the atomic mass of atoms, we're going to consider the mass of a proton and the mass of a neutron essentially equal. So the way you get atomic mass of some atom of helium, you just add the protons and you add the number of protons to the number of neutrons. So in this example, we had 2 protons and 2 neutrons, so the atomic mass of this isotope of helium was 4 AMU. And then this isotope, where we had 2 protons and 3 neutrons, was going to be 5 atomic mass units. So anyway, I'll leave you there. In the next couple of videos, we're going to start talking about, and I defined a few terms, I talked about how to have a helium atom, what defines it as a helium atom is that we have 2 protons, and I also have been mentioning this word isotope a lot. So I'll hopefully in the next video get into those terms and actually give you good solid definitions of what those terms mean. So anyway, thanks so much for watching, and I'll see you in a future video.